Today we are starting our lesson number 4, which is Introduction to Cisco Routing Protocols. So yesterday we came to know that we design a network and we configured the IP address, but our PC were not communicating, right?
Yes.
So due to routing problems, right? So today we'll come to know routing protocols introduction, and then we'll come to know about routing configuration. Okay, same. So these are the topics we will come to know how to cover it.
Mm-hmm.
Okay, so first of all you have to understand what is routing. So what is routing? See, routing is the process that forward packet from one network to another network. Yes, routing is used to create communication between different unreachable network. Means if you want to create communication between unreachable network, you can communicate with the help of routing. And one more benefit is there with the routing is that routing helps you to find best path. Like suppose if you have two path, okay, two path to reach any destination. So the routing protocol will find, okay, this path is best or this path is best.
Yeah.
Okay, like this. If you have here, if you have this router and you want to send any packet, so that this router will send that, okay, I want to send through MTN, or maybe I want to send through Airtel kind of thing. Okay,
Yeah.
because if you have two ISP, from both ISP you can reach Google, right? Okay,
Yeah.
but your router will forward data from which, through which ISP, or it will do load balancing. All depends on the routing protocols. Okay, now here we have one lab. Okay, now here you can see that you have 192.168.10.0 network, which is different. Here also you have 20 network, right?
Right.
Okay, now you tell me, if this PC wants to communicate to this PC which belongs to 20 network, do this PC can communicate to this one?
Excuse me?
I'm asking that. Let me erase it again. See, here we have one network which is 192.168.10.0, right?
Right.
So here I have configured 10.1, here 10.2, here 20.1 and 20.2, right?
Yeah. Right.
Okay, so this is the router, but no
Yeah.
routing is not configured here.
Yes. Yes.
Okay, routing is not configured here, but I'm saying that without routing, do this PC could communicate to this PC?
For the moment, without routing is impossible.
Impossible. Okay, so
Yeah.
can we verify?
Yes.
Okay, so let's open this lab. So here we can take one router. Here we have to take one Ethernet switch. Okay. Okay, now we can take some computers. So two computer will connect with switch 1 and two computer will connect with switch 2. Now connectivity Ethernet, Ethernet 1 to Ethernet. Okay, so here our lab is ready now.
Yes, it's already now.
Okay, so here we are using 192.168.10.0/24 subnet, which is totally different. And here we are using
20.
20. So we can start the devices. And then we can take console. Okay, so let's come to PC1. PC1 IP address is 192.168.10.1 and the subnet mask is this one and the gateway is 10.10. Save. Let's come to PC2 IP. You can assign like this also 10.2/24 like this also. Okay, instead of writing 25524, but only in PC. Okay, on R1 router we have two interface E0 by 0 and E0 by 1, right? Conti interface E0 by 0 IP address 192.168.10.10 no shut, and then interface E0 by 1 IP address is 20.10 no shut. Save it. Control Z, you can see here I have written Control Z, right?
Right.
It's not written, I just press console Control Z, you will get it here. Now we can verify. So IP interface brief exclude unassigned. See, IP is okay.
It's okay. It's
Now
okay.
come to PC3 IP 192.168.20.1/24 and the gateway is 20.10, right? Okay, now let's come to PC4. So PC4 IP is 20.2 and then save. All is okay. Now if you'll come here on router 1, if you are typing here so IP route, see no routing configured. If you check here so IP protocol, no protocol is running, right? There is no any protocol is running. Okay,
Use it.
yes, no application is running now, but PC1 will try to communicate to PC2, same network 10.2, no problem. PC1 can communicate, but when
Yes.
PC1 will try to communicate PC3 20.1c is communicating without routing, but yesterday it was not working, right?
Right.
Now see how it is working. When the packet is coming here, the ping packet is sent by PC1. Okay, this ping packet.
Okay.
So ping packet is coming to switch. Switch is forwarding to router this interface. Why? Because the PC is using this interface as a default gateway, right? Then when
Yeah.
the ping packet is coming to R1, R1 is checking that do I am reachable to 20 network, right? So R1 any router, right? They have their own routing table. Routing table is one kind of map. Okay, like if I will tell you that okay, go to someplace, okay, Nairobi something, or maybe like Kigali, okay. So you'll say, okay, let me check in my brain or in my map, do I know Kigali, where is Kigali? So see, if you'll open like this, R1 will check his own routing table like this. So IP route, R1 is saying yes, it is there in my routing table. This is the routing table of the router.
Yeah.
Is yes, I know route 20 network. So whenever any packet is coming, and it's saying that yes, 20 network is connected with me, and it is connected via E0 by 0, E0 by 1. So when a packet is coming, it's saying yes, I know 20, let me forward it and stop. That's why
Okay.
whenever any network is directly connected, then you can communicate, no problem. In that condition, there is no need of routing. See, in this condition, no need of routing.
Okay.
But problem will come here.
When we have many routers.
Yes, when the network is unreachable, see, router 1, right, this router 1, if this router 1 will check its own routing table, so that router 1 will get 10 and 12 but no 20, right?
Right.
So in that condition, 21 is not reachable from him by default, right? It's not directly
Right.
connected. So if any network is not directly connected to you and you are not reachable and it's not there by default in the routing table, in that condition you have to configure routing.
Yeah.
Okay. So here we need to configure routing. Okay.
Okay.
So if you want, I can show you through practical also. But yesterday we have seen, right? So we configured two router, we configured
Yes.
IP, but these computers were not communicating just because of they were not reachable to this one, right?
Right.
Yes. Okay. Now again we are talking like what is routing. So routing is performed by routers or layer 3 device. So routing is basically done by routers, but if any device is also performing like a layer 3 means OSI layer 3, okay, network layer, which works at the network layer in the OSI model, okay.
Yeah.
So on those devices you can perform routing. You cannot perform like in the like a normal device like switch or something like that, right? Routing you can perform only on those routers or device which works on layer 3. Like you can configure routing on firewall also, but it will not work efficiently, okay. Means it will not work like a router. See, router is especially made for routing, firewall is especially made for blocking the incoming packets and outgoing packets, right?
Right.
So but in the firewall also you can configure routing, it will work, but it will not support all the features as router is supporting, okay.
Okay.
Now you can perform routing in layer 3 device also, okay. So layer 3 device is what it act, layer 3 device, or you can say layer 3 switch. Layer 3 switch act as a layer 2 switch as well as a router, means it works like a both.
Mm.
A router is a networking device that forwards the packet based on the information available in the packet header and the routing table. So when any packet is coming to the router, router checks that this packet has to reach to which destination. So the destination information is there in the packet header. So according to the destination information, router checks its own routing table, and on the behalf of this routing table information, router forwards the packet. If it is available, it's not that if it's not available and router is forwarding. If it is available, router will forward. If the information is not available, router will drop the packet. Now, a routing is a process of selecting a path along which the data can be transferred from the source to destination. Okay. Routing is for routing is a process of selecting best path, okay, for transferring the data from source to destination, of course. That is also one kind of routing.
Mhm.
And I told you that routing is always performed by mm, a preferred device which is known as router. Okay, you can use routing with different device also, but router is especially made for routing.
Yeah.
Now every time we are talking about some best path, right? So if I have multiple path, right, to reach any destination, so maybe my router is selecting some best path, but how router is selecting best path? So router is calculating some kind of measurement that, okay, no, from here is 1 kilometer, from here is 2 kilometer, from here is 3 kilometer, right?
Yeah.
So those calculation method or measurement method is known as metric. So metric is a calculation process or method used by routing protocols for best path selection process.
Okay.
Now there are multiple protocols, okay? So we use different type of metric calculations. Okay, now
Mm.
for example, here you are saying hop count, bandwidth, delay, load, reliability, MTU, okay, multiple things. But I'm saying that, but this all is used by different routing protocols. Okay, now
Okay.
no problem. Let me come back here. Now, for example, like I'm just giving example on metric. Like milk, right?
Yeah.
Okay. So if I'll tell you to measure the milk, okay, so you will use what? Kilogram or milligram or gram?
Uh,
So milk is
gram.
measured in kg or liter?
Liter.
Liter. Very good. Okay. And if I'll tell you to measure rice,
In kilogram.
kilogram, right? So all is calculation method, right?
Yeah.
But different object, different calculation method, right?
Calculation method.
Yes.
Yeah.
Okay. Now, one more thing. Administrative distance. Okay. Now,
Okay.
route whatever routing protocols we are using, each and every routing protocols use some kind of administrative distance number. That is default. If you want, you can change, but right now we are talking about default. Okay, so by
Okay.
default administrative distance is uh, sorry, by default every protocols will have administrative distance, and on the behalf of administrative distance we find who is more trusted or who is more best. Okay,
Okay.
now for example, I have two car. Okay, one is OSPF and second one is
Yeah.
RIP. This is my
Okay.
car. Okay,
Okay.
and I want to go from Congo to Rwanda. Okay,
Yeah. Okay.
so I will compare. I will say that, okay, which car I should use, RIP or OSPF. So
Yeah.
see, everyone has the number. Lowest number is the best. Okay,
Okay.
now so in if you will compare, you will say no, OSPF administrative distance is low. Low means it's better. Okay,
Okay.
higher
Okay.
means bad.
But
Yes, or not best, you can say, not bad, but you can say this is not best, this is best,
mm,
this is second best. Means if you have two
okay.
car, so you have to compare with administrative distance, so automatically your router will pick OSPF to drop packet from source to destination.
Yeah.
Okay, understood what is administrative distance? See, administrative
Yeah.
distance is a number given to each and every routing protocols to differentiate who is
Okay.
best. Okay, but if
Okay.
you have a single car, then can you compare?
No, it is impossible.
Yes. But when you have multiple protocol running on a single router, in that case you can compare. No, let's please send my data through lowest administrative distance number protocol. Okay.
Okay. Okay.
Now, so what is metric? I gave you example, some example, right? So metric is a distance calculation method used by routing protocols. Done?
Okay. Well,
Okay. Now each and every routing protocols use different type of metric calculation. Like for example, see these. Can you see all these objects?
yes.
All is measurement object, right?
Yeah.
Spoon, thermometer, scale, liter, something like weighing machines. All is there, but all is measurement kind of thing,
Yeah.
right? But they use to measure different object.
Yeah. Yeah.
Okay.
Okay.
Now, so metric is what? It's a calculation method for used by routing protocols, and each and every routing protocol use different metrics. And how when we will come to know about routing protocol metric, when we will use protocols, like which protocol we use, which type of metric. Okay. So basically, you can always keep in mind that metric is used by dynamic routing protocols, not via static and default. Okay.
Okay.
Okay. See here. We have types of routing. So there are two type of routing: interior gateway protocol. Just a second, let me change. Okay. So mainly the routing protocols are divided into two sector. One is in-house and second one is out
Also.
outside. Okay. In-house means inside company. Okay. And outside
Okay.
means outside the company.
Yeah.
Okay. Now, so the company use IGP protocol, interior gateway protocol. But when company wants to communicate to another company, at that time they use EGP protocol for communication. This is BGP. Okay. So when you
Yeah.
will come to know about CCNP, then you will know about these all protocols. Okay.
Okay.
Okay. But in this lesson, or in this uh, what you can say, the lesson what we are learning, it's all about IGP. We will come to know static, default, dynamic, inside dynamic, RIP, EIGRP, OSP. Okay.
Yeah.
So the metric calculation what we came to know, those metric calculations are used by dynamic routing protocols, not via static and default.
Okay.
Now, so type of routing protocol, we have a static routing protocol, default and dynamic. Okay.
Dynamic.
Yes. Now, static routing protocols. So static routing protocols are configured when you know the destination. Okay.
Okay. Okay.
Default is used for unknown destination. So default is basically used for internet access. Internet access. Okay. When you are
Okay.
connected with ISP. Okay. Dynamic routing protocols are used for connecting branch. Okay. You know, your company have multiple branch in a city. So in that
Yeah.
case, you can use dynamic routing protocols to communicate between your branches. You know, even Axis Bank. Do you have Axis Bank there, or GT Bank?
Yes, I do. Yeah.
Yes. So if GT Bank is there, like 5 or 10 in your city, so all those GT banks, they communicate together with the help of these dynamic routing protocols. Okay.
Okay.
But inside your house, we use their default routing to communicate internet. So you know, inside our small company, maybe like the institution what we are talking to open, right? So
Yeah.
we need one internet connection, so our computer can communicate to the internet. So at that
Yeah.
condition, we have to configure default routing on our router, so our internal computers can go outside and communicate to the internet.
Yeah.
Okay. Static routing was the first routing. Okay. And when the routing came, when the network came, at that time internet was not like bigger like nowadays. Okay,
Okay.
so a static was used for a small organization. Okay,
Okay.
yes. And we'll come to know why a static is not in use, or maybe why a static should be used. We'll come to know all those things. Okay,
Okay.
but as of now we have to know that yes, we have three type of routing protocol: static. So a static routing will be configured only when you know the destination, means how to go
Destination.
and where to go.
Yeah.
Okay, default is for unknown, means I want to
Mm.
reach internet but I don't know how to go.
Okay.
Okay, and I don't know where to go, but I want internet. But static will tell you that yes, if you want to go Yahoo, YouTube, Facebook. So you have to configure all those address manually.
Mm-hmm.
But in default, no need to configure. Just configure that yes, I want to communicate. So take example that can you configure a static routing nowadays in your network that yes, I want to communicate Yahoo, Google, Facebook, Messenger. There are millions of website, millions of network. Can you configure? No, it's not possible, right?
No, not possible.
Yes. So in the companies for internet access, they use default routing. Okay? And dynamic, I told you we use for branch communication. Okay,
Communication.
we can configure dynamic routing only between your own routers, company routers. Okay,
Okay.
now, so a static routing, what is a static routing? A static routing is also known as non-adaptive routing. Non-adaptive means it static routing do not share any information with another neighbor, but dynamic they exchange information with neighbor.
Okay.
It is a technique in which administrator manually adds the routes in the routing table. Means the map what we have checked in the router as with the command show IP route. So that routing table, normally dynamic routing protocols make that routing table automatically.
Okay.
But static routing, when you will configure static routing, means in that case administrator like you have to configure static routing manually.
Manually.
Yes, we'll see that one. A
Yeah.
router can send the packet for the destination along the route defined by administrator. So a router will only forward those packets, okay, which is defined by administrator, okay, which is defined. It's not that router will forward all the packet, okay.
Okay.
Now, in this technique, routing decision are not made based on the condition or topology of the network. Means right now what is saying here, like suppose if it is connected like this, okay, maybe your router is connected like this and this is your topology, it's connected. So if maybe one topology is down or disconnected, or you added one another topology, so these topology what you are changing or adding new, okay, so it will not automatically take effect. Administrator has to add manually and remove manually. But in
Mm.
dynamic routing protocol, whatever condition or topology is there in the network, according to that routing table will be updated. Okay.
Okay.
But static routing is not like that. It if you want to update, your administrator will manually update. Okay. And if you want to remove, you have to manually remove. Okay. That's
Yeah.
why it is little bit like difficult when you have a large network. Maybe you are sleeping at home and your engineer will call, sir, network is down, please add a new link, remove a new link. So how you will do that? So you want
Mm.
something automatic, right?
Right.
That's why most of the people prefer dynamic routing, not static
Right
and
thing.
default. Yes.
Yeah. Yeah.
But each and every routing have their own use. Okay.
Okay.
Now, now let's come to know about default routing. So default routing is a technique in which router is configured to send all the packets to the same hop ISP. So whatever data you are giving to the router is just forwarding to ISP and saying ISP that yes, I'm paying for this public IP address. Please, you are responsible to provide the communication to the internet. Please allow me to communicate. Simple.
Okay.
But default routing is configured when you have a single exit point. But when you have multiple exit point, at that conditions, default routing is not a best solution. Okay.
Okay.
Now, if you have a static routing also configured and default routing is also configured for the same destination. Okay. So if you have both default and static is configured, so static is best as compared to
Default.
default. Very good. See how? See, static administrative distance is 1 and default is not there. Default administrative is also 1. Okay. But static is best as compared to default. Okay. We'll come to know while configuration. Okay.
Okay.
Now dynamic routing protocol. So dynamic routing protocol is known as adaptive routing protocol. Adaptive means they adapt the information of its neighbor. So if the dynamic routing protocols are ready to exchange the information between neighbors. Okay, like suppose here is one router, here is one router, here is one router, like this. Okay, here this router is connected with one network, this router is also connected with one. Okay, so this router 1, router 2, router 3, router 4. Router 1 know about router 2. Router 2 know about router 1 and router 3.
Okay.
And router 3 know about router 2 and router 4.
Four.
But do router 1 know about router 4?
Yes.
No, by default they don't know. My friend.
No, because it's
Yes, it's connected, but I'm saying by default.
By default, no.
By default they don't know. Like suppose, you know, like human chain. So this is one guy. His hand is connected with one other person. So do this person know directly him? Directly to R4? No. Okay. So R4 is sending the information to R3. R3 is sending information to R2. R2 is sending information to R1, and then R1 know about R4.
Okay.
Okay, that's why it is known as adaptive routing. They exchange the information and they adapt the information of the neighbors.
Okay.
Okay, now it is a technique in which a router add a new route in the routing table for each packet in response to change in the condition or topology of the network. So whatever packet is sent, add whatever I'm saying, like the routing table. You remember I told you that router take decision on the behalf of routing table, right? So automatically if there is any changes, okay, routing table will be automatically change, new route will come. If you are removing any network, automatically that route will be deleted. Okay, and for each destination there will be a single route or single path. Route or path is the same thing. Okay, don't get confused. Route means what? Route. Okay, path is also same thing. So for each destination, router will have its own separate path to reach that destination.
Okay.
Dynamic protocols are used to discover the new routes to each to reach the destination. Okay, so I told you this one, that dynamic routing protocols will have separate path to reach destinations. Okay, they do not deal with a single exit point. Okay, means you can configure with the single exit point, but normally dynamic is configured for multiple exit points. In dynamic routing protocols we have RIP, EIGRP, OSPF. Means we have different type of dynamic routing protocols. So we'll see RIP, then we'll see, okay, this was the problem in RIP, then they developed this different protocol, then they developed this protocols. We'll see the changes and development of the protocols. Okay, the enhancements of the protocol.
Okay.
If any route goes down, okay, then
Okay.
the automatic adjustment will be made by the routers to reach destination. Remember I told you, if there is any changes, automatically they say okay, no problem, let me exchange the real, means like exact information how to reach that destination. Okay,
Okay.
now the in dynamic routing protocols there are some conditions of communication. Okay, so that condition of communication we will come to know while configuration. That okay, suppose if I am RIP and you are EIGRP, both is dynamic. Okay, but by default they won't able to communicate. So if you want to
Mm.
communicate, so both router must use same routing protocol. See, if I'm speaking English and you are also speaking English, then we are communicating. So right, but it's not that you are
Right.
speaking French and I'm speaking English, so we cannot communicate, right?
Right.
Yes, same here. Dynamic routing protocol must be same on both router for communication.
Yeah.
Now what is routing table? So remember last time I gave you the example of routing table. Routing table is one kind of map of the router. According to routing table, router take the decision of forwarding the packet from one network to another network, right? Inside
Right.
routing table, you will have the network information of connected network as well as neighbor remote networks. Then if you are getting some network via any neighbor, right, so that neighbor router information will be there. Then to reach that destination network you will have the information of outgoing interface. Means if you have maybe multiple interface, so if this PC wants to reach to some specific network, so this router will forward that packet via which interface.
Okay.
And how to check routing table? Remember we checked with this command, so IP route, right?
Right.
This command, so IP route. Okay, now very important question. Okay, now suppose I have lab like this. Let me copy this lab. Okay, now if any data is coming towards router 1 from his own network, this is the router 1 network. So this router, sorry, this computer wants to communicate Google. Okay,
Okay.
so the packet will come to R1. Okay, R1 will see that I have two ISP, ISP1 and ISP2.
Two.
So R1 will think that I should forward data via R1 or sorry, ISP1 or ISP2. Okay,
Okay.
I getting. Now, so if R1 is forwarding via this one, ISP1, so which type of condition R1 is following to forward via ISP1, not via ISP2? Are you getting?
Okay.
Okay. So there are three conditions. First is longest prefix match. Can you check the first one? Longest prefix match.
Perfect. No.
Longest prefix match means, okay, can I zoom little bit or we can use
Okay.
this. So the first condition is longest prefix match. Longest prefix. Now we'll see here which one is the longest prefix. Okay. Now tell me if this PC wants to move from wants to communicate to Google, right? So can you
Right.
see Google subnet mask? Here is /24 and here is /26, right?
Right.
So which one has the longest prefixed or longest subnet mask? ISP1 or ISP2?
I think it's the ISP1.
No, longest. Here is
ISP2.
okay, now let me explain you. Suppose I will ask from you that where are you? Okay.
Okay.
Okay. So tell me, where are you?
In Bukavu, Congo.
Okay. You are in Bukavu, Congo. Okay. Wait 1 second. Bukavu,
Congo.
Congo. Okay. Now I will ask your brother. I will ask from him that, okay, my friend, where are you? So he will say, I am in Congo.
Yeah.
Okay. And I will ask from your friend. He will say, I am in street number 2, Bukavu, Congo. Okay. Now
Yeah.
tell me, who is correct, who is wrong?
The last one
No,
is correct.
your brother is wrong. He's not in Congo.
It's not in Congo.
No, I'm just giving
The
example.
last address you give.
No,
You give the okay.
I'm
Okay.
saying I'm giving example. Your brother
Yeah.
will say I'm in Congo, but still he's correct, right?
Yeah.
You are also correct,
Yeah.
and your friend is more correct.
Okay.
He's saying I'm in street number 2, Bukavu, Congo. Means he's more correct. You are
Yeah.
also correct. Your brother is also correct.
Okay.
But if I will travel to Congo, so where I will find him? In Congo? At least I can come to see, okay, I want to go Congo, Bukavu, and here at least I can try to find where is Yasin, right? But
Right.
it will be little bit difficult.
Yeah. Yeah. Yeah.
But for your friend, I can go to Congo, Bukavu, street number 2. I can easily find him, right?
Right.
Yes. That's why here here the longest prefix, whoever have the longest prefix, that route will be preferred first. Okay,
Okay.
means this is best, this path is best.
Okay.
Okay. Okay, now another condition will come, that okay, if both side prefix is same, 26 26 for example, okay,
Okay.
then if the longest prefix is matching from both ISP1, ISP2, okay,
Yeah. Okay.
then it will check the lowest administrative distance. Okay, now tell me, here you are connected to ISP1 via which routing protocol?
Static.
Okay, and here you are connected to ISP2 via which routing protocol?
Dynamic.
Yes. Okay, so what is the RIP administrative distance? 120.
One
And
120
static administrative distance is
is one.
1. So now tell me, it will compare. So which one has the lowest administrative distance?
Static.
Static. So it will prefer this path.
Okay.
Okay. Now
Okay.
it will say, okay, both is using same, static here, or maybe RIP here, also RIP here.
Yeah.
Okay. Then it will go to the third condition. Third condition is a metric calculation. Means, what is the distance from here to here? Is it a 1 kilometer? Here, what is the distance? It is a 1 kilometer or 2 kilometer. Okay, but I'm just giving example in kilometer, but they check in a hop count. No, hops means how many gateway I'm crossing to reach the destination.
Mm-hmm.
Okay, so here you'll say I'm crossing, maybe like is a single gateway. Okay,
Okay.
single gateway, or if it is a different, then it will select, okay, here is high gate means here they have a multiple gateway, here is a single gateway, so it will prefer this path. But if according to this condition, okay, according to this condition, if all is okay here all path is equal, right? Okay, so you can
Well,
see here, note, if all the above three statement will match, then the router will go for
balancing.
load balancing. Okay,
Okay.
so router use uh, three process or three statements. Okay, according to that three statements, router find that which path is best or which path is second best, or I should do load balancing. It all depends on the routing condition and topology conditions. Okay,
Okay.
so these things you have to remember for exam perspective. This is the default administrative distance, and you can see here lowest will win. Okay. And how lowest will win? When you have multiple protocol running on a single router. In that case, the lowest routing protocol will be preferred to send the data.
Okay.
Okay. So we are done with this introduction to routing protocol.